Let us solve quadratic equation which has degree of 4. Question is, find the roots by factoring. X to the power of 4 plus 3x squared equals to 4. We can rewrite this equation by substitution. We can substitute x squared as y. In that case, x to the power of 4 will be equals to y squared, right? Substituting, what do we get? We get y squared plus 3y. Let us bring 4 to the left side. Minus 4 equals to 0. Now it is a familiar equation where we can factor using product and sum. Product of two numbers we are looking for is minus 4, and the sum of two numbers should be plus 3. The numbers are 4 times 1. 4 positive, 3 negative, correct? So you can factor this as y plus 4 times y minus 1 equals to 0, right? So y is x squared for us. So we could write this as now back in terms of x. X squared plus 4 times x squared minus 1 equals to 0. Now x squared minus 1 could be written as difference, product of difference and sum, right? This is difference of squares. So we get x squared plus 4 times x plus 1 times x minus 1 equals to 0. Now we have three factors, and from these three factors we could expect three solutions, right? Okay, so the first factor is x squared plus 4. When is it equal to 0? The second one is x plus 1 equals, we have to equate that to 0, and the third one is x minus 1 equals to 0. If you are doing in the domain of real numbers, then we get solution x equals to minus 1 and x equals to plus 1. So in the domain of real numbers, x squared plus 4 is always greater than 0. So no solution here, right? But if we change our domain, right, is say if we have domain of complex numbers, now this question is from IB higher level maths, and they are actually solving it in the domain of complex numbers, right? So where x belongs to complex numbers, if I add that, in that case we have two solutions here also, right? So we have here x equals to plus and minus square root of minus 4, which is equals to plus and minus 2i, correct? So in the domain of complex numbers, we have four solutions for the equation, and in the domain of real numbers, there will be only two solutions. I hope I am correct. So I'll write down all the four solutions here. It all depends how you get this question, right? So in case the domain is real numbers, then there will be only two solutions, correct? So for the time being, since I am assuming the domain to be set of complex numbers, I'm writing my solutions as plus and minus 2i and plus and minus 1. Okay, thank you.